Okay, I found a slightly bigger board, about twice as big as the one in my office, so we'll try this one out. So what we're going to look at now is we're going to crunch some numbers on the total cost. So we just learned about total cost, and as we're going to define it right now, the total cost is going to be the fixed cost, which is kind of like a one-time cost, plus a variable cost. Variable cost. Okay, so what we're going to do is we're going to apply that idea to each of the light bulbs. We got a CFL, we got an incandescent, and we got an LED. Okay, so we'll start with the incandescent. Now, if you remember, the incandescent had a fixed cost of 50 cents, and it had a variable cost of $0.006 per hour. Okay, those are the data points. I'm going to draw a line here between these two. So the incandescent bulb, let's put some color around. Let's make it colorful. So it's got a fixed cost of 50 cents. So the total cost of the incandescent bulb is you have to go to the store and buy the bulb. So even before you use it, if you buy it and then bring it home and put it in the shelf and never put it into a bulb and turn it on, it's going to cost you 50 cents. So that's assuming you don't use it for any hours. So what I'm going to do right here is I'm going to create a little column, number of hours. And we're talking about number of hours that we're going to use the bulb. So if you don't even use an incandescent bulb at all, the total cost is going to be equal to, this is going to be the total cost of the incandescent, it's going to be the 50 cents that you had to buy it, plus, now I'm going to write this out, although it's going to seem kind of silly to write it out. I'm going to write out 0.006 times 0. So you've got $0.006 per hour times 0, which is just 0. So that entire total cost is going to be a whopping 50 cents. So it's going to cost 50 cents even if you take the bulb, buy it, and never put it into a light. There you go. Straightforward, right? Hopefully pretty straightforward. Okay, it gets more interesting when we actually start putting the bulb into a light fixture and using it. So let's put it in and let's leave it in for 10 hours. Let's put it in and leave it in for 10 hours. Now when I say leave it in for 10 hours, you don't have to actually put it on and then leave it burn for 10 hours. You could very easily put it on for half an hour a day for 20 hours. That would add up to 10 hours. Or you could put it on for 15 minutes a day, a quarter of an hour a day, for 40 days, and that would also be 10 hours. So 10 total hours of being burned. I'll put burning. Burning number of hours. Okay, so for 10 hours, the total cost would still be the 50 cents you start with. You still have to buy the bulb. And then we're going to be charged $0.006 for 10 total hours. So if I do that, that's 50 cents plus, now this is where I chose 10 for a reason. I didn't want to have to use a calculator to do any of this math in my head. 10 times 0.006 is just going to move that decimal and bring the puppy dog over here. So it's going to be 0.6. Instead of 0.6 cents, it's going to end up just being 6 cents. So if I move the decimal point, actually I pointed to the wrong spot. If I move this decimal point that way, it ends up just being 6 cents. So it's going to be 50 cents plus 6 cents, which is a grand total of 56 cents. So if I buy the bulb and then burn it for 10 hours, it's 56 cents. Let's burn it for 100 hours. Let's burn it for 100 hours. Again, I'm using multiples of 10 because I don't feel like using a calculator to have to do all this. So still, again, you have to purchase the bulb for 50 cents. And then we have to multiply the 0.006 times 100. Same idea with the decimal point. It's now going to move boop, boop, 2 spots over, which is going to be $0.6, also known as 60 cents. So it's 50 cents to purchase, 60 cents to run. That's going to be $1.10 total. $1.10 total. Hopefully you're seeing kind of the pattern. And you can put any number you want in for the number of hours. You could put 1, 2, 3, 4, 10, 20, 30, 40. It does not matter. It doesn't matter at all. Because the total cost is dependent on these two things. And those two things, if you have the values for, you can run them and do them exactly like this. Is making sense so far? Hopefully, maybe. Okay. Now, we also need to, I'm going to move the camera because we are super high tech here. We need more board. This is why I moved over here. Let's take a look at the CFL. Okay? Now the CFL, and we'll make that a different color. We'll make that green because they are often touted as more eco-friendly. The CFL, if you remember, it's okay if you don't, it had a fixed cost of $3. And it had a variable cost of $0.0014 per hour. Yes, $0.0014 per hour, 0.14 cents per hour. So it's a lesser variable cost. It's a higher fixed cost, but a lesser variable cost. And hopefully that makes sense. Okay, now what I'm going to do, I'm also going to draw a line right across here, just like that. I'm going to do 0, 10, and 100 hours for the CFL, just like I did for the incandescent. So 0 hours would mean we buy the CFL and put it on the shelf and never use it. So that would be the fixed cost of $3 plus the variable cost, 0.0014 times 0. That would just cancel, become 0. It wouldn't cancel, it would just become 0. So it would just be $3. So 0 hours, $3, which is essentially just the fixed cost. Boring, right? Yeah, boring. Let's not talk about that anymore. Let's do it for 10 hours. Next up is 10 hours. You still gotta buy the bulb. But now we're going to take that 0.0014 and multiply it by 10. And again, using the whole idea of decimals, multiplying this by 10 is going to move that over by 1. It's going to become 0.014 or 1.4 cents. So if I add 3 to 1.4 cents, it's going to be 3.014. So just a little bit more than $3.01, almost $3.01.5. Cool so far? Okay, maybe. Let's do 100 hours. Same thing, costs $3. But then we have to add to it 0.0014 times 100 hours. Move this over to, boop, boop, that is 14 cents, $0.14 or 14 cents. This is now $3.14. Now what's kind of fun about this is we can look at the costs of the incandescents and we can look at the costs of the CFLs, and you can see that they're both getting more expensive as we burn them for more hours, which hopefully makes perfect sense. But even after 100 hours of burning, the incandescent is still cheaper than even just the purchase price of the CFL. Even just the purchase price. So now what I'd like to do is we're going to pick the camera up again, and we're going to move to another board. I'm writing bigger than I thought I was going to be writing. We're going to need one more board to look at the LEDs. So now we're going to do the LED, and we'll make this one red, just because I used orange and green already. Okay, and then we're going to do number of hours burned, just like we did on the other side. Fixed cost of an LED was $5, and the variable cost was the least out of all of them. It was $0.001 per hour. So that's what we need to know in order to crunch the math for the LED bulb. So for the hours burned, I think we went 0, 10, and 100. 0, 10, and 100. Okay, it's very glary. You know what? I'm realizing something. Rather than run over there and fix the blind, I'm getting that feeling I got when I was doing Pythagoras with you all the other day. I think this might be the time for a better solution. And And I think that better solution is Microsoft Excel. As crazy as that sounds, I think we want to use Microsoft Excel to do this. This is the kind of stuff Excel was built for. So why don't we stop this video, head into the office, and learn how to code our first Excel spreadsheet. I'm pumped about this. I think you will be too. We'll see you in there.